Before we get into graphing quadratic equations, we want to have some kind of idea of what our graph should look like. So again, a quadratic function is one in the form of ax squared, this 2 is important, plus bx plus c, where a is not equal to 0. That would just mean that there would no longer be an x squared term. So a quadratic function is going to have a term raised to the second power. Now, the graph of a quadratic function is going to be a parabola. And your parabola is either going to open up like this or open down like this. And these are rough sketches, but they're U-shaped. That's what a parabola is. And we're going to focus a lot on A here, which is called our leading coefficient. So if you hear me refer to the leading coefficient, I'm talking about whatever the coefficient of x squared is, because that's going to give us some information about these U-shaped graphs, these parabolas. Here's some more important information. It says that, and this is what I just told you, the graph of this function is a parabola. If a is positive, the parabola opens up. So in this case, it's opening up. That would mean our leading coefficient is positive. And if it's negative, then our leading coefficient is negative, then the parabola opens down. That's like this example. If our a was negative, the parabola opens down. Along with that, obviously, this point at the very bottom, the vertex, would be a minimum. Of course, if it's on a graph that looks like this, that's opening down, that point on this very rough looking graph here would be a maximum. The other thing we need to pay attention to is the vertex. Now that's this point I was just referring to here. That's called the vertex. It has an x-coordinate of negative b over 2a. That's going to play an important role when we go to graph. So the vertex is going to always fall, the x value of the vertex will be at negative b over 2a. Now the axis of symmetry is this vertical line x equals negative b over 2a. Parabolas are symmetric. You can fold them in half. So in this case, our negative b over 2a is 0. So this line here, the y-axis, is x equals 0. That's the line of symmetry. Over here, maybe we said that this line here is 3. Our axis of symmetry would be x equals 3, a vertical line through 3, because we could fold the parabola on itself. Don't stress too much about that. So now to graph, we have 3 steps. The first step is to use this negative b over 2a and find the x-coordinate. Then step 2 is make a table of values. Basically make an input-output table using values to the left and right of your vertex. And then you plot the points and connect them. So let's look at an example. It says sketch the graph of y equals x squared plus 3x minus 4. Again, this is ax squared plus bx plus c. So the very first thing, step 1, says find the x-coordinate of the vertex, negative b over 2a. So we have negative, what's our b? It's 3, over 2 times our a value. Well, there's nothing listed there, but we know there's 1 x squared there. So we can go 2 times 1. This works out to be a negative 3 over 2, or just a negative 1.5. So that's going to be the x value of our vertex. Step 2, make a table of values, including values to the left and right of that negative 1.5. So again, I don't care if you make a vertical or a horizontal input-output table. Just make sure that you include negative 1.5 in the middle. And I'm going to do a couple to the left and a couple to the right. And you get to pick these. My advice, because remember, if you look at our pictures here, they kind of go up steeply or drop steeply. So you don't want to veer too far away from that vertex. So maybe I'll use like negative 3 and negative 4. And again, I'm just picking these in 0 and 2. Try to use 2 on each side though, so you get a good idea of the shape. Now what I'm going to do is I'm going to take these input values and I'm going to plug them in here for my x's. And I'm just going to take a calculator and I'm going to go negative 4 squared plus 3 times a negative 4 minus 4. When I do that, I end up with 0. Then I'm going to do the same thing, but this time instead of using negative 4, I'm going to input my negative 3. If I input my negative 3 here, my output is going to be negative 4. Now I'll input my negative 1.5 for x into this function, and I get out a negative 6.25. If I input 0, I get out a negative 4, and if I input 2, I get out 6. Okay, so just like input-output tables we made with linear functions, we're going to be doing with quadratic functions. Notice how I put parentheses around my negative 4? That's a good idea. Again, your calculator doesn't like to treat this as a negative 4 unless you put it in parentheses. So now let's plot these points. We have a graph here, so I'm going to plot the point negative 4, 0, and -3, -4, -1.5, so I'll just estimate it here, -6.25, so it'll be a little bit past the 6, 0, -4, and 2, 6. Okay, you can kind of see the smooth curve here just by plotting those points. We know this is going to be our vertex because we used -b/2a. Now, here's the tricky part. Connecting these, the smooth curve. And just do the best you can. Obviously, I'm going to try it one more time here. And I'm probably going to do worse. But you guys get the idea. Okay, you're supposed to connect it and get a U-shaped figure here, and I apologize that this is so bad, but you get the idea. Okay, this is what your parabola should look like. You have your vertex, and you see it's going a U shape in either direction. Now our line of symmetry, just to point that out again, is, remember, is at a -1.5. So if I would draw a nice U-shaped figure here, it would fold in half right at x equals -1.5. So again, to graph parabolas, you first find the x value of vertex, -b/2a, make an input-output table with a couple numbers to either side of your x-coordinate of the vertex. Then you plot the points, and good luck drawing your smooth curve. Do the best you can.